Okay, now how does this one relate to your biomedical image processing? So how actually, what happened when this sampling and quantization in image in digital image or in two-dimensional image? Okay, before that, let's me discuss something that I forget. Okay, let's say if you want, okay, let's okay, now the problem is, of course, that is the limitation of a digital signal. You can see that because the process of digitization, okay, from the sampling and quantization process, you can see at the end of the process, you actually you know, you lost a lot of information, because once you digitize something, many part or many value have been removed. You only left, the one that left is the one that can be stored, okay, or can be set through the one that is the one that can have been set there, meaning that it depend on the capability of your system, how many point that you can set, you can save. Okay, so that's why, okay, one way to improve the performance in term of course, uh, by having a sampling or quantization process, you lost a lot of data. So how actually you can remain the information, which is, you know, you want to have something, okay, you want to have a digital signal that can have a lot of information and it's close to your analog signal. Okay, of course, the one way you can improve is by having, you know, increase a lot of point here. Okay, of course, if you having this, for example, you have a lot of point here. Okay, now if you have a lot of point there, then you will, you know, have a something which is almost close to your analog signal. If you have many impulse response there or stems there. Okay, of course, by having this kind of things, actually you can have something like this if you increase the resolution. Okay, the resolution or the, okay, that resolution is actually, okay, this resolution is actually is called a sampling resolution, meaning that if you increase the sampling resolution, you will actually, okay, you will actually the more point there you can remain. Okay, the more point you can remain, so the more point you can remain, which mean the more point you lost while converting during the sampling process. So meaning that by increasing the resolution or the sampling resolution, the digital image you produce over here will close to your analog signal, which is very good for your system. Okay, same goes to the quantization. For quantization, the one that you want to increase is this one. Okay, this red dot here. If you can increase the red dot here, okay, meaning that now there's a lot of point in vertical axis can be remain or can be stored, which is later when you produce something here, you will produce something which is close to your analog signal. So the process of increasing this one is also known as a resolution, but this resolution is actually is called intensity level resolution. Intensity level resolution. Okay, this one is called sampling resolution. Okay, now let's focus on two-dimensional image. What happened there? Okay, in two-dimensional signal or image, digital image, okay, which is this one, I still draw the same things there. Okay, same goes to the one that I've discussed before. when we talk about sampling, okay, when we talk about sampling, actually it's a process of digitization of uh, horizontal axis, but in image or into two-dimensional signal case, the horizontal axis is this one, which is your x and y plane. Okay, quantization is a digitization process of your vertical axis. Okay, if you talk about the quantization, it refers to this one, your fxy. Okay, so now it's same to the same as your digital signal. Okay, sampling talk about the horizontal axis, while quantization talk about vertical axis. So again, sampling, there's a sampling resolution, right? Sampling resolution, while quantization actually is you have the what we call as intensity level resolution. Okay, this is the one that will determine the capability of your system, whether you can remain more information or more numbers, so the system can, you know, close to the analog signal. Okay, the digital signal we produce is depend on these two resolution in order for your digital signal to remain the information that you taken from the analog signal. So the highest the resolution, the more close your digital signal to your analog signal. So same. Okay, now sampling is related to sampling resolution, quantization is related to intensity resolution. So if you talk about sampling resolution or in image, okay, in digital two-dimensional digital image, this one is also known as, okay, this one is also known as spatial resolution. Spatial resolution. Okay, spatial resolution actually is related to, again, sampling is, since sampling is related to horizontal axis, whilst if you talk about the sampling, actually is also, you need to know that there's a resolution called sampling resolution, okay, or also known as a spatial resolution, also related to sampling. So spatial resolution is actually when we want to increase the sampling resolution, actually you are increasing this one, okay, this box here, this small box here, the x and y plane. So if you want to increase the spatial resolution, meaning that by having higher sampling resolution, you will have a very small square there, or very small box there. Okay, the higher the resolution, the more small the box there, or which is also known as your pixel. Okay, so the higher the spatial resolution, the higher the pixel. So that is the one always you heard when you buy a digital camera. When you buy some digital camera, they give you some spec where this camera can obtain 10 megapixels, 20 megapixels. Actually, that resolution, we in the market, they call it as a resolution, but for image processing, that resolution is known as a spatial resolution, because the higher the spatial resolution, okay, so the small and more fine pixel you have, meaning that in one image, actually it's produced by a very small pixel, or very small box there. Okay, that actually is referred as spatial resolution. While that you must differentiate between spatial resolution and intensity resolution, because intensity resolution, okay, it's something will determine how many level here, okay, how many level you can have in your f layer or in your vertical verticals uh, vert vertical axis here. Okay, the higher the resolution, the more fine point there you can have to have some numbers which is come from the analog image. Okay, again, from here, the one things that I will like to highlight is that previously when I talk about, okay, if you go back to this slide, okay, if you go back to the previous slide, which is this one, or maybe yeah, this one. Okay, if you realize that we have discussed about 1 bit per pixel, 8 bit per pixels. Okay, grayscale is 8 bit per pixel, that's why you can store from 0 to 255. This one is 1 bit per pixel, also known as a binary image, because you can store the element depth either 0 or 1. 1 bit per pixel over here is actually your intensity level resolution. Same goes to this one. Okay, this one 8 bit per pixel is your intensity level resolution. The unit is 8 bit per pixels. So back to our discussion over here, why this number is actually, I call it as a intensity level resolution, is because if you can see here, if if this image, okay, this is actually image, actually you just imagine that your eyes is here. Okay, this is your eyes. Okay, your eyes is looking at that image. If this is a grayscale image, normal grayscale image, the intensity resolution is, as I mentioned in the previous slide there, should be 8 bits per pixels, meaning that you can have a numbers from 0 to 255. So what is the meaning from 0 to 255? Meaning the f should be, your f can go up, okay, start from the 0 to 255. So meaning that it can go from 0 here up to 255 here. Okay, so this is the value. So you can have this red line here up to 256 level. From 0 should be 256 levels. So from 0 to 255. So that is actually referred as intensity level resolution, meaning that this one actually your intensity level resolution. Okay, sorry, I forget to put this intensity level. Okay, intensity level resolution. However, for spatial resolution, what is spatial resolution? Let's say this is my image. Okay, then I said this is the intensity of this image is, intensity level resolution of this image is 8 bits per pixel. So meaning that each and every value inside this box here you can have numbers from 0 to 255, which is grayscale. So the intensity the spatial resolution of this image is actually a 3 times 3 pixels. That is actually your spatial resolution. Okay, because you have 1 2 3 1 2 3, so you have 3 times 3 or 9 pixels. Okay, so I hope you can differentiate what you can differentiate between what is sampling resolution, spatial resolution and intensity level resolution. When we talk about the spatial resolution, is actually this resolution that you always find in your digital camera. Okay, we talk about 50 megapixel. Actually, when we talk about 50 megapixel, means that you have a 50 mega or 15 million pixels in one image. For my case over here, only 9 pixels. So that is actually referred to your spatial resolution. While there's another resolution called as intensity level resolution, where actually that is actually referred to how much level you can have in your vertical axis, or I can also consider as how much color, possible color. For example, for grayscale, if you have 0 to 255, means that you have a 256 possible color, from black to white, and then you have a gray, dark gray, a little light gray, light gray, and so on. From 0 to 255, you have a 256 possible color to be represent inside the image. Okay, but however, again, like I said, in your computer, the normal grayscale is always have the fixed value of intensity level resolution, which is 8 bit per pixel. And again, like I said in the previous class, we also have image like CT scan can have the intensity level resolution which is 16 bit per pixel, means that it can go from 0 to 65 or 64K. Okay, so that number, which is in the unit of bit per pixel, is actually your intensity level resolution, which should be differentiated with your spatial resolution, where the spatial resolution is the number of pixels or the number of box that inside your image. Okay, so I hope that by having this discussion, you can get to know and identify what is a spatial resolution, what is an intensity level resolution, and how does this relate with the quantization and sampling. Because of course, sampling is if you talk about the spatial resolution, actually that resolution is come from the sampling, while the intensity level resolution is come from the quantization.